Hi everyone, welcome to section 2. In this section, I'm going to talk about Redshift infrastructure. Now, we'll be taking a different approach. I'll talk about Redshift in an isolated mode, meaning that I will make you understand how Redshift works, how to load data in Redshift, how do you connect there, and do multiple operations in Redshift. Once we understand the entire Redshift architecture and its feature, then I will talk about the integration of Redshift with other services, how Redshift fits in the entire data engineering pipeline or in the data lifecycle. So let's start with the infrastructure part. First of all, what is Redshift? By now you already know that Redshift is a data warehouse on AWS cloud. It can be used as a data warehouse. You can use it as a data mart, which is a subset of data warehouse. So you can have a Redshift cluster as a data mart, or you can have Redshift in your entire data mesh. Redshift was launched in February 2013. So as of the recording, Redshift has been in existence for more than 11 years. Before Aurora was launched, Redshift was the fastest growing service or product in AWS. So that's how famous Redshift was. Even today, Redshift is the second or third largest or third fastest growing service in AWS. A lot of customers, thousands of customers, use AWS Redshift globally. The formal definition of Redshift is that it is a fully managed petabyte scale data warehouse service in AWS cloud. That's what Redshift is. Now, Redshift provides various types of infrastructure offerings. Redshift provides something called provision cluster and serverless. Now, in this infrastructure or in this section, I'm going to talk about Redshift provision cluster. So I have a separate section on Redshift serverless itself. So before diving deeper into Redshift, let's understand what a cluster is. The definition of cluster is that it is a group of identical servers. The servers can be either physical or virtual, or nodes that work together as a group. The boxes that I'm showing you are servers. So as I said, it can be physical servers or virtual servers, or it can be EC2 instances also. So as you already know that EC2 instances are virtual machines or virtual servers on AWS. So if you combine them all together and they are connected to each other in a cluster. So if I take this definition forward in a Redshift cluster, one Redshift cluster would contain multiple EC2 instances which are connected to each other. So that's what a Redshift cluster would be. Of course, it is way more than that, which I'll discuss in future slides. But this is a high level overview of what a cluster is. Cluster is nothing but a group of physical servers or virtual servers or EC2 instances on AWS. So obviously in AWS we'll be talking only in terms of EC2 instances. So a Redshift cluster is nothing but a group of EC2 instances which work together collectively. Now all these EC2 instances are connected to each other using high-speed network connectivity. So you can create a Redshift cluster using AWS console or AWS CLI, which is AWS command line interface, or AWS SDKs, which is software development kits. We can have AWS SDKs in Java, Python, .NET, C Sharp, etc. Or we can use Redshift APIs also, which can be sent over HTTP requests. In our course or in our sessions, we'll be using AWS console. Maybe at the end, I will show you how to create a Redshift cluster using AWS CLI or command line interface. Now let's go ahead and take a look at the AWS console for Redshift. I hope by now all of you have AWS account created. If not, please go ahead and create an account. So this is my AWS account and this is the landing page of AWS console. If I open the account, this is my account ID, which is of course blurred. The name of the account is data engineering and I have my personal information. So this is the account that I have created using my email ID. And when I sign in using aws.amazon.com, and when I click sign into console and mention and provide my credentials, it takes me to this landing page. Now here, of course, I have these recently visited services, but if you are new to AWS console or AWS account, you will not see anything here. So how do you go to the AWS Redshift page? So in this search box, you type Redshift and then it will show you the Redshift option. So you can click on this star. So if you click on this star, it will come into your favorites page. So you can click here and go to the Redshift console. So this is the landing page of the console. And if you scroll down, there are a lot of documentations, there's a lot of literature here in the landing page. Now on the left hand side, you'll see this burger menu or the menu list. If you click here, you can see these options are available. So let's go through the options one by one. The first one is Redshift serverless. Of course, we'll not talk about Redshift serverless yet. We'll talk about it later on. We'll do hands-on using Redshift serverless later on. Then the second one is provision cluster dashboard. So it will show you how many provision clusters you have created. As of now, you do not know what a provision cluster is. We'll talk about it shortly. Then we have these clusters. Here you can see how many clusters have been created, how many provision clusters have been created in your account, or you can click on create cluster and create the new Redshift cluster for your use. Then we have query editor and query editor v2. This is used to run ad hoc queries in the Redshift database. We can use other tools also, by the way. Then it talks about Redshift data shares, which is a feature that we'll discuss later on. Then you have zero ETL integration, which is another feature of Redshift. Then you have Redshift IAM identity center connections. We'll not talk about identity center as such. And then we have Redshift configurations, where we can see workload management, subnet group, hardware security module connection, and management of tags. Then we can also see something called Redshift partner integration. Here it shows Informatica data loader, which can be used to load data in Redshift. Then we have some other options. So this is in a nutshell the Redshift console. When we start hands-on, we'll be using this cluster console or the provision cluster dashboard a lot. So let's go back to the presentation now. Now in the console, you have seen Redshift provision cluster. So let's talk about the clusters. But before that, we need to talk about Redshift nodes. What is a node? There can be two types of Redshift nodes. One is the leader node and the other one is compute node. I will cover leader node and compute node in Redshift architecture in much more detail. But as of now, these are the two types of nodes or Redshift nodes that we see. While creation, we only create compute nodes. We do not create leader nodes because leader nodes are provided to us by default and without any cost. So when you create a Redshift cluster, we only create or provision the compute nodes. Now, obviously, it begs a question, what is a node? So let's say this is a Redshift cluster and we have something called a leader node and compute node. These are nothing but EC2 instances. So all of them collectively work together. They have high performance network connectivity between them and they work together as a group. So these individual servers or EC2 instances are called nodes. So in Redshift, we have leader node and compute node. Now let's zoom in to the compute node. So what does a compute node have? So again, it is similar to a server. It can be a physical server or a virtual server. In our case, of course, it is a virtual server or a virtual machine, which is nothing but an EC2 instance. So a compute node would have CPU and RAM. So CPU is for processing, RAM is for memory, and then associated high performance SSD storage. So that's what a compute node is. Leader node would also have the same thing, but we do not have any visibility of leader node in the Redshift cluster because that is provisioned for us by default. So when you create a Redshift cluster, we essentially create compute nodes only. So a compute node is nothing but combination of CPU, RAM and high performance local SSD storage. Now there can be various node types in Redshift. So what is this node type? This is nothing but the EC2 instance type of the compute nodes. So Redshift provides multiple EC2 instance types, which are also called node types. The first node type is RA3 node type, and it was launched recently. RA3 node type is of course a compute node. It is not a leader node, because when we create EC2 instances for Redshift cluster, or when we create Redshift nodes, we do not provide the leader node, we only provide the compute node. So this is an RA3 node. I have named it as RA3 node 1, which is a compute node. It has its own CPU, RAM and local SSD storage. The SSD storage is attached to the node. So this is the compute node type. In addition to the local SSD storage that is attached to the compute node in RA3 node types, this node or this compute node or this RA3 compute node has access to an external storage also. And the access is done via a fast network, but the storage is hosted by Amazon S3. So in addition to the local SSD storage, the RA3 nodes have access to Amazon S3 storage. There's network connectivity between compute node and S3. So if you see here, it is a very unique architectural pattern. So here what Redshift provides using RA3 node is separation of compute and storage. So I have the compute here and then I have the storage here in addition to local SSD storage. So I can expand this storage irrespective of the compute. So if I have to store more data, as it is on S3, I can store a lot more data on S3. But if I do not need more compute power, I can just do with one RA3 compute node. I do not need to add any more compute nodes. But let's say I need more compute, I can add additional RA3 nodes also. So which will have its own local storage, and it will also have access to Amazon S3. So if you see here, we can scale the compute separately than that of the storage. If I need more compute processing or more power to process my complex queries, I can add more RA3 nodes without touching the storage. So I do not have to scale the storage. I can scale the compute separately. So it works both ways. Either you scale the compute independently of the storage, or you can scale the storage independent of the compute. Now the question is, Amazon S3 is an object store. Does it mean that the data that will be stored in S3 would be stored in object store when it is used with RA3 nodes in Redshift? The answer is no. It is stored as block storage. Each block is approximately 1 MB of size, and the data is actually stored in these blocks. So initially the blocks are written in the local SSD storage, and when the local SSD storage is filled up, it is written to Amazon S3. Now in S3 also it is written as block storage. It's not object store. Meaning that if you have data in S3 and you want to update a particular row or a single row, you can do that, because Redshift does not store data in S3 as object store. It writes data in S3 in blocks only, which are of size 1 MB. Now this is handled by a separate node in S3. A separate program runs in the S3 compute nodes, which handles this writing and reading of blocks in S3 itself. Now this entire storage architecture, where you have mix of local SSD storage and block storage in S3, is called Redshift Managed Storage or RMS. The data is stored in local SSD storage, and whenever the local storage is full, the data is stored in S3 and it is handled by Redshift Managed Storage. We do not have to do anything here. So what does it give you? It gives you additional capabilities, because you can store the SSD for hot data meaning the data that you access regularly, and you can store the cold data in S3, meaning that the records which are not accessed that much can be stored in S3, again as blocks, not as object store. Now the access is not slow. So because the network connectivity is fast and we have blocks stored in S3, so whenever you read any record, these blocks are read by the RMS software and sent to the compute nodes. It does not have additional latency, and also the price is similar. So whenever you use RA3 nodes, whether you use local SSD storage or S3 storage, the pricing is same. So SSD storage can be used for hot data and S3 storage can be used for cold data. Now, as I said, this is called Redshift managed storage. And the network between the compute nodes and S3 is very high bandwidth networking, which is built on top of AWS Nitro system. So the capacity and the bandwidth of the network is very, very high. So that's why you do not see any latency, even if the data is stored in S3 as blocks. Because of this architectural advancement, Redshift can do automatic data placement across the tiered storage. Because you have local SSD for hot data and S3 for cold data, the data placement can be handled by Redshift automatically. We do not have to do anything here. So the automatic data placement considers various options. The first one is data block temperature, meaning that which data blocks are read pretty often. What is the frequency of a particular data block? If the frequency or the number of times a data block is read is pretty high, that will be a high temperature block. And if a data block is read less number of times, the temperature of that block would be less. So high temperature blocks would be stored in local SSD storage and low temperature blocks would be pushed to S3. It also depends on data block age, meaning that when was the data block last accessed. So if the data block was accessed for a long time ago, then that block need not to be on local SSD storage, that can be pushed to S3. And another consideration is workload patterns. So Redshift takes a look at the workload patterns, and based on that, the data placement is done across the tiered storage, which includes local SSD and S3. So the next node type is DC2. Now it is an older node type and it is very much different than that of RA3 in a way that here the storage is not separate than the compute. So this is a DC2 node 1 where we have CPU and RAM and local SSD storage, and the Redshift data is stored in local SSD storage only. There is no Amazon S3 involved here. There is no external storage here. Now if you have to increase storage, you have to add one more node. Even though you do not need compute, you'll have to add one more node if you need more storage. In other way around, if you need, let's say, more compute, you'll have to add one more node even though you do not need more storage. Now you might ask a question that why don't we use RA3 node types all the time? So there's a rule which is mentioned in the Redshift documentation also. So if your data size is less than or within 1 terabyte, you should use DC2 node types. But if you think that your data would grow, then you should use RA3 node types. There's one more node type which is called dense storage, and it has been deprecated. What it does, it instead of using SSD storage, it uses hard disk drive or HDD storage. Now let's take a look at the instance types or the node types of RA3 and DC2. So this is again taken from documentation. So if you see, there are four RA3 node types: RA3 XL Plus, which is used for single node; RA3 XL Plus for multi-node; RA3 4x large; and RA3 16x large. So I have introduced a new term called single node and multi-node. So what is this single node multi-node? Single node means that your leader node and compute node would be on the same node. And multi-node means that the leader node and compute node would be on separate nodes. RA3 XL Plus can give you 4 vCPU and 32 GB of RAM. There's something called default size slices per node. We'll talk about slices later on. And the managed storage limit per node is 4 terabytes and 32 terabytes, meaning If your storage size is more than 4 terabytes, then you cannot use RA3 XL plus single node. Or if your storage size is more than 32 terabytes, you cannot use a single RA3 XL plus multi-node. So you have to use multiple RA3 XL plus or RA3 4x large and RA3 16x large. So RA3 4x large gives you 12 vCPUs and 93 gigs of RAM. RA3 16x large gives you 48 vCPUs and 384 gigs of RAM. So these are the slices per node and these are the managed storage limit per node. Then we have dense compute node types, which is DC2. There are two variations of this node type. One is DC2 large and the other one is DC2 8x large. DC2 large gives you 2 vCPUs, 15 gigs of RAM and 160 GB of NVMe SSD. DC2 8x large gives you 32 vCPUs, 244 gigs of RAM and 2.56 terabyte NVMe SSD per node. And you can get a total capacity of 5.12 terabytes from DC2 large and 326 terabytes from 8x large. You can create from 1 to 32 nodes in a single cluster using DC2 large, and using DC2 8x large you can create anywhere from 2 nodes to 128 compute nodes. These node ranges are there in RA3 node types also. Using RA3 XL plus you can create only one node, of course, because it is single node. You'll have the leader node and compute node in the same node. Using RA3 XL plus multi-node, you can create 2 to 16 compute nodes. Using RA3 4x large, you can create 2 to 32 compute nodes. And using RA3 16x large, you can create 2 to 128 compute nodes. And this is the total capacity that you can get from RA3 nodes, which ranges from 4 terabyte to approximately 16 petabytes. Let's understand the Redshift cluster topology for provisioned clusters. So it starts with a VPC. So VPC is nothing but a private network in AWS cloud. You already know what a VPC is. This VPC is created in two AZs. The region has two AZs. It can have more than two AZs also. So if you create a VPC, it will be created in all the AZs in a region. So let's say this region has two AZs and the VPC has been created in these two AZs, AZ1 and AZ2. Now what you do is that you create subnets, one or more subnets in these AZs. So let's say I create subnet 1 in AZ1 and subnet 2 in AZ2. Of course, I could have created 4 subnets in AZ1 and 4 subnets in AZ2 also. But for simplicity, I am showing you only through 2 subnets. Now these subnets can be public subnets or private subnets. So if you're using Redshift, even if you are doing POC in development environment, you should create those subnets as private subnets. After you create the subnets and when you go ahead and create the cluster, you mention the compute nodes. So let's say I mention 2 compute nodes in subnet 1, which is in AZ1. So this is a single AZ Redshift cluster wherein I have created all the compute nodes in a single AZ in maybe 2 subnets. Again, I'm showing you only one subnet, but typically it would be 2 subnets. But if you want to create Redshift cluster in multi-AZ, of course, I'll be adding more compute nodes in the subnets which are in AZ2. So in this case, subnet 2 contains compute node 3 and compute node 4. So now it becomes a multi-AZ Redshift cluster, having 4 compute nodes in 2 subnets in 2 different AZs. This is the Redshift cluster. If you use RA3 node types, then you need access to S3 also. Now this access is done using high bandwidth AWS Nitro systems. So the compute nodes will have access to Amazon S3 because Redshift managed storage includes the local SSD storage and the data blocks in Amazon S3 also. Now because we need access on S3, we need to have an IAM role associated with the Redshift cluster. So this is how the cluster topology looks like at a very high level. We have VPCs, then we create one or more subnets in a single AZ, and then we launch single AZ Redshift cluster. By provisioning, compute nodes only in one AZ. If you want to create multi-AZ Redshift cluster, we provision compute nodes in multiple subnets across multiple AZs. And if we use RA3 node type, then we need to access S3 also, for which we need to assign an IAM role. We need to assign IAM role for DC2 node types also, because we'll be loading data from S3, we'll be unloading data to S3, or we need to have integration with other AWS services. So definitely we need to have an IAM role associated with the Redshift cluster.